Hey everybody, welcome back. In this video, make sure you've already watched my two videos on section 6.1 because in this video we're going to be building on the concepts and techniques that we learned in 6.1. So here we're going to be focusing on 6.2, which is real applications of normal distributions. So there were three cases that we saw in 6.1 for normal distributions, but all of the normal distributions in 6.1 were standard normal distributions. 6.2 is going to be non-standard normal distributions. Okay, so let's go ahead and see what we're going to be learning today. So this section presents methods for working with normal distributions that are not standard. Okay, that is, the mean of a distribution is not 0, or the standard deviation is not 1, or both. The key is that we can use a simple conversion that allows us to standardize any normal distribution so that the same methods of the previous section can be used. Okay. So I'm just going to refer to the previous videos from the previous section because I'm going to assume that you've already watched them and done your homework from there. Okay, so what we're going to be using is if you have a non-standard normal distribution, the values of that non-standard normal distribution are actually going to be represented by the variable x. Okay? So in order to convert a non-standard normal distribution, which I call x-scores, into z-scores, which are the standard normal distribution, you have to use the z-score formula, which we've seen before. We've already calculated z-scores earlier in this class. But now we actually get to see how useful this formula is. So the formula is z equals x minus mu all over sigma, where x is the original data value, mu is the population mean, and sigma is the population standard deviation. And because I'm going to be teaching using table A2, we want to always round our z-scores to 2 decimal places. Okay? So this formula allows us to standardize any normal distribution so that x values can be transformed to z-scores. So just to kind of summarize this process, what we're starting with in this section is we're starting with an x-score. I call them x-scores. But our book might not necessarily call them x-scores, but they use the variable x, so that's not too far-fetched to call them x-scores. Okay, so if you start with an x-score, then how do you convert an x-score into a z-score? Well, you use the conversion formula that we just saw. Okay, so let me show you what I mean. You start with an x-score. You use the conversion formula, z equals x minus mu all over sigma. And then this gives you z-scores. Okay. So this conversion formula allows you to take x-scores, which are from a non-standard normal distribution, into z-scores, which are standard normal. And you might be wondering, well, why do we need to convert them to z-scores? Why do we even have to do that? I mean, why can't we just leave them as x-scores? And the answer to that is basically, if you want to use a calculator, you may be able to just type in the x-scores, and it may find the area for you automatically as long as you enter in mu and sigma. But if you're using a table, like table A2, you have to have z-scores in order to calculate the area. So it has to be standard normal. So the reason we're converting to z-scores is so that we can use table A2, which is the standard normal table that we covered in great detail in the last video from 6.1. Okay, so that's the process. And we'll be using that z-score formula, which we've seen before. Okay, so let's return to the slides while I erase all this. Okay, so this is the picture. They have a very similar picture to what I just described in the book. The figures illustrate the conversion from a non-standard to a standard normal distribution. The area in any normal distribution bounded by some score x, as in the figure on the left, is the same as the area bounded by the corresponding z-score in the standard normal distribution. So all that's really new here is that you need to notice that the reason we're allowed to convert them to z-scores and look them up in the table is because a non-standard normal distribution and a standard normal distribution have the exact same shape, okay? But you might notice the only difference between non-standard and standard is in the middle you have a mean of mu for a non-standard, and your standard deviation would be sigma for non-standard. Whereas with a standard normal distribution, we can just write z-scores, where 0 is the mean and 1 is the standard deviation. Okay. Hopefully you find this whole process to be not too challenging, because really all we have to do in the problems from this section is we just use the conversion formula to convert x scores to z scores, and then we use the techniques we learned in the last video from 6.1. Okay, so let's jump into an example. So this is a word problem taken from our book. So it says heights of men are normally distributed with a mean of 68.6 inches and a standard deviation of 2.8 inches. Find the percentage of men who are taller than a shower head at 72 inches. So basically all you have to do here is identify x, mu, and sigma. Write those down, plug them in to the conversion formula, and then look up the area in table A2. Okay, so first of all, let's identify x, mu, and sigma. So because they're asking us to find the percentage of men who are taller than a shower head at 72 inches, that's the same as saying, well, taller is the same as greater than. Okay, so what they're asking us to do is we need to figure out the probability that x is greater than 72 inches. So probability that x is greater than 72. And greater than goes to the right. So this is going to be the area to the right that we discussed in the last video. Okay, but in order to use table A2, as I keep saying over and over again, we have to use the conversion formula. So using the conversion formula, z equals x minus mu over sigma. Here we can see that x is going to be this number here, okay? So x is 72. How do I know that? Well, whatever you have inside of your inequality, this 72 is the same as the x score. Okay, so here x is 72. And then the mean is the same as mu. We've talked about that many times. So the population mean here is going to be mu, and we can see here that that is 68.6 inches. All right, and then the last thing we need is sigma. Standard deviation is sigma, and that here is 2.8 inches. So that is sigma. And when you're doing your homework from this section, quite a few of the problems you just need to label it like this so that you do it correctly. And once you have it labeled, it's not too incredibly difficult. So we're going to be using the z-score formula. So we're going to do z equals x minus mu over sigma. Okay? And then we just plug in the numbers that we have. And we need to grab our calculator. So let me go get my calculator. Okay? And I know I haven't told any jokes in a while on my videos, so I figure like I should tell another joke, even if you don't find my jokes funny. So before we go any further with this problem, I wanted you to know that whenever you're opening the door to a refrigerator, you should always knock first. Why is that? We can stop the video and think about it, see if you know the answer to that. Okay, and the answer is you should knock first in case there's a salad dressing. That's right. Okay. All right, so anyway, what we got here is z equals x minus mu over sigma. So plugging everything into this formula, this is going to give us a z-score. So x is 72 minus mu is 2.8 all over sigma. Whoops. I mixed up mu and sigma. Well, that happens, so I'll just leave it in the video. So try that again. X is 72 minus mu, which is 68.6. Good thing I caught that. All over sigma, which is 2.8. Okay, so that's just all the numbers plugged into the z-score formula. And then on our calculator, we can go ahead and do 72 minus 68.6. And then that gives us 3.4. And then 3.4 divided by 2.8 will give us our z-score. So I got a z-score of z equals 1.21. And we want to round to 2 decimal places. So the thing is, when I've used this formula, what it gives me is the exact same format, but now instead of x, I'm going to be writing z. So what we're finding here is the probability that z is greater than 1.21. So I got 1.21 when I typed all of this into my calculator. Okay, so I just used the z-score formula. I plugged in x, mu, and sigma, and then I rounded to 2 decimal places and rewrote the original problem with a z-score. And then once you get it to here, this is stuff that we've done in the last video. So I'm going to go through the rest of the problem a little bit faster. So now that we have the probability that z is greater than 1.21, we can look this up in table A2. Just remember that greater than goes to the right. So since greater than goes to the right, this is going to be the area to the right. And the formula for the area to the right, as you know from my last video, is 1 minus the area in table A2. Okay, so area to the right. Now that we have a z-score, we can go ahead and use this. Area to the right is going to be 1 minus the area in table A2. All right, so we look up z equals 1.21, and that's going to give us our area in table A2. So let's go ahead and open up the table. Okay, so let me turn off the camera so that we can actually see. All right, so we said our z-score was 1.21. So obviously 1.2 is a positive number, so we're going to be on the page that says positive z-scores. And 1.2 is the first two digits, that's our row. And then our column is 0.01 because the last digit is a 1. So where 1.2 and 0.01 meet gives us our area, which is 0.8869. Okay, 0.8869. So the area in table A2 that we just looked up is what we plug in here, 0.8869. And then because it's the area to the right, greater than goes to the right, we're going to be doing 1 minus 0.8869 on our calculator, and that will give us the actual answer that they were asking for. Okay, so we're going to do 1 minus 0.8869 gives us 0.1131. 0.1131. And just remember that you can also write that as a percentage. That's a decimal, but in the original question, they asked us for a percentage. So just remember that 0.1131, if we move the decimal 2 places to the right, gives us a percentage of 11.31%. And then it was a word problem. And this is an unusual case where they actually ask for a percentage as their answer. However, in your homework, it's usually going to be decimals. Okay. All right. So let's go ahead and return to the slides while I erase all this stuff. Okay. So the example that we just did was covered in detail in our book as well and on these slides. So as you can see, they've actually drawn out the normal curve here. And remember, regardless of whether it is standard normal or non-standard normal, it's still going to be a bell curve. So it has the same shape. So when you look up the area, the total area under any normal curve or any density curve is always going to be 1. So that's why we're able to use table A2 after we convert to z-scores. Okay? So taller means greater than. That's why it's the area to the right, because greater than goes to the right. And then, as you can see here, they got the same z-score that we did. Z equals 1.21. Okay? And then using table A2, they got 0.1131. However, the only reason I'm going over this part of the slides is they make an interesting point. If you aren't using table A2 and you're using a calculator or computer software to find that area, you might have gotten a slightly different area, which is 0.1123. There's nothing wrong with that. And in fact, 0.1123 is closer to the real value than what we got. But when you're doing your homework quizzes and exam for my course, it has a margin of error, which means that it will accept a range of different values with no problem. So if you want to just use the table the way I have been, you're welcome to. Or if you want to get fancy and use a calculator, you're welcome to use that as well. Just keep in mind that technology is a little bit more accurate in some situations, but table A2 also works great. Okay, so that is an example of area to the right. I'm not going to do an example of area to the left because it's too easy. We did lots of examples in the previous video, and when you're using the z-score formula, you're just going to convert each z-score sorry, you're going to convert each x score to a z-score, and then you just need to decide whether you're area to the left, area to the right, or area in the middle. So I'm just going to do one more example in this video. So in our next example, I did want to take a look at one of your homework problems so you can see how we're going to interface with MyMathLab. All right, so actually let me switch the view here. There we go. Okay, so looking at this, if I zoom in, that will probably help so we can actually read it. In this problem, this is question number 6 on your homework from 6.2. We want to find the area of the shaded region. The graph to the right depicts IQ scores of adults, and those scores are normally distributed with a mean of 100 and a standard deviation of 15. So before we go any further with this problem, I want you to think about whether this is a standard normal distribution or a non-standard normal distribution. You're welcome to pause the video if you need to think about it, and then unpause it when you think you have an answer. Okay, so the answer is it's non-standard normal, as you might have guessed, because all the problems in 6.2 are non-standard normal. That's the whole point of 6.2, is we're doing non-standard normal and we're having to convert them to standard normal in order to look up areas in the table. Okay, so how do we do this? Well, just like on the last problem, we have to identify x, mu, and sigma, but here they actually have a picture drawn. And we'll notice, just looking at this picture, everybody can see that we're finding the area in the middle between 108 and 126. So think about it for a second. What do you think x is going to be here? Again, you can pause the video if you need to. So the answer is there are actually two values of x here because we're doing the area in the middle. So just like in 6.1, when we were doing the area in the middle and we had two z-scores, here we have two x scores. So looking at this, we have x is 108 or x is 126. Okay, so those are values for x. Okay, so the way we would write this, if we wanted to use the same notation as we did on the last example, is because it's the area in the middle, we're going to have the probability that x is greater than 108 and less than 126. Okay? And then, of course, we also need to identify mu and sigma. So let me switch to a view so we can actually read this. So here we can see that they say the mean is 100. So that means mu is 100. And then the standard deviation is 15. Remember that the standard deviation is the same as sigma. Okay. You know, if this thing would work, that would be nice. There we go. That took way too long. Okay, so mean is 100, so that's mu. So we know that mu is going to be 100 in this problem. And then sigma is the standard deviation, so sigma is 15. In fact, let me write all that so that we don't have to keep trying to read over what's already written. So mu is 100 and sigma is 15. Okay, and then we just need to, actually, because we have two x scores here, these are considered the x scores, 108 and 126. We have to use a conversion formula for both of them. so that they're both z-scores. And then we'll be doing the area in the middle formula that we learned about last time. Okay, so let me switch to just the camera so it's easier to read. All right, so what we're going to be doing is we're going to be converting these using the z-score formula. So z equals x minus mu over sigma. So for the 108, x is 108 here. So we're going to be doing 108, that's x, minus mu, which is 100, all over sigma, which we said was 15. Okay, so that is the z-score formula for this one, and then we can do the same thing for this one. So if you think about it, once we're using this formula, it's now in terms of z. So this is actually going to be something like this. So over here, we're going to have, once again, x minus mu over sigma. So that's going to be 126 minus 100 over 15. Okay, and then we want to just type these into our calculator and round to 2 decimal places because they're now going to be z-scores. Okay, so we've got 108 minus 100 is 8, and then 8 divided by 15 is going to give us our z-score on the left, which is 0.53. Okay, so this is going to be the probability of 0.53. That's our first z-score, is less than z, is less than, again, entering this into our calculator for the right z-score, 126 minus 100 is 26, and then 26 divided by 15 gives us a z-score of 1.73. Okay? And then now that we have these written as z-scores, now we can just notice that because we have 2 values, we need to look up both of these areas in table A2. And then remember that this is the area in the middle case. Okay, so whenever you have 2 z-scores, that's always going to be area in the middle. And recall that the area in the middle formula that we learned in 6.1 is the larger area minus the smaller area. So that was the easy way of thinking about it. So area in the middle is larger minus smaller. So why don't you go ahead and pause the video and try looking up both of those areas for that z-score. And then when you unpause the video, I'll go ahead and show you how to do it just in case you need to see that. Okay, so now that you've unpaused the video, let's go return to table A2, our favorite table. So let me open that back up here. Okay, so when we look at 0.53, 0.5 is going to be the row, and 0.03 is going to be the column, and that's a positive z-score. So if we go ahead and go turn this thing off, 0.5 is our row, 0.03 is our column. So for your first area, when you look up 0.53, you should have gotten 0.7019. Okay, so 0.7019. And then for the other one, for 1.73, your row should be the first 2 digits. So your row should be 1.7, which is positive, and then your column should be 0.03. Okay, so 1.7 is our row, which is down here, and then our column is 0.03. So the second area that you should have gotten here is 0.9582. 0.9582. Okay, And then if we return to our work here, these are the two areas. So which of these is the larger area? Obviously, the 0.9582 is the larger, and the 0.7019 is the smaller. So the formula for area in the middle is larger minus smaller. So that's going to be this larger area, which is 0.9582, minus this smaller area, which is 0.7019. Okay. So let's go ahead and do that on our calculator. You can feel free to pause the video and just type it in. Not too hard to do, just subtraction here. So for our subtraction, what did we get? We got 0.9582 minus 0.7019, which is 0.2563. Okay, so this is 0.2563. So what we just found there, the larger minus the smaller, is the area in the middle. And if they asked for a percentage, we could convert that to 25.63%, but they didn't. So they wanted you to leave it as a decimal. So 0.2563 is what we would type in on our homework. Keep in mind that the homework problems are randomly generated, so you're going to have to go through that whole process that we just went through when you're doing your individual homework. But as you can see here, they say round to 4 decimal places as needed. Well, that was already done by the table. So we have 0.2563, and we're not writing it as a percentage, we're writing it as a decimal. Okay. And if you used a calculator or computer software, you might have a slightly different number. But fortunately, MyMathLab has an algorithm that allows for those subtleties. Okay, so that's good stuff. Thank you for watching, and I will see you on our next video. Okay. Have a good one.